Hello friends, how are you? In previous class we discussed about the effect of change of temperature on the states of matter. Now I am starting its second part, that is effect of change of pressure. Like temperature, pressure also play an important role in changing state of matter, because change in pressure make the particle closer or far enough, and as you know, when the particles are closer or far enough, then there is change in attraction forces, which results change in state of matter. To understand it, we can perform an activity, or in simple words I can say, we can say that with activity we can understand it. Suppose this is a cylinder and there is a piston. There is a piston piston is a device which create pressure in normal life, that in Holi, the back part of the pichkari that you pushed and the water comes out, like a simple example of piston. Similarly, in injection, the backside part on which we press with our thumb, that is a piston, which is used to increase the pressure. Okay, so there is a cylinder and there is a piston. Suppose that is a gas. When we increase the pressure by pushing the piston, the particles comes closer, and when we apply more pressure, then particles comes close enough. And when the particles comes close enough, you know that attraction forces increased, and when the attraction forces increase, then the state of matter change from gas to liquid or solid can also. Now there is a theoretical explanation of it. On applying pressure, the particles of matter can be brought close together. That means they comes closer. It results decrease in interparticle space between them and increase in attraction forces, because when the particles comes close, the attraction forces will increase. Okay, when the particles come close enough and attraction forces becomes high, the state of matter can be changed from gas to liquid or solid. Because when the particles comes closer, the attraction force is increased and particles attain a definite shape, a definite position. Like here that was random, but now that is definite, and you know that when the definite pattern of particles appear, then gas convert into gas, or in gas convert into liquid, or sometime in solid also. Two examples of our daily life are helping to understand it. One is LPG and second is CNG, are examples of this phenomena. Here, by increasing the pressure, we convert them into liquid. That means liquefaction of gases. LPG, liquefied petroleum gas. CNG, compressed natural gas. In both cases, the gases compressed under high pressure. That's why they convert into liquid form. Okay, now a topic which is related with liquefaction or the effect of pressure, that is dry ice. That is dry ice. The question is, what is dry ice? The solid carbon dioxide. The solid carbon dioxide is called dry ice. It's called dry ice. Now the two questions comes in our mind: why it is ice and why it is dry. I will discuss about that. After that, how it is formed. When carbon dioxide gas is stored under high pressure and low temperature, it directly convert into solid form, which looks like ice, white colored. Okay, that's why ice word is used. Now let me discuss why it is dry. To understand it, let me proceed about it. When pressure is released, then it directly convert into gas. When pressure is high, gas to solid. When pressure is released, solid directly to gas, into gas. That means liquid state is absent. Okay, that's why the word is used dry. Clear? Since liquid state is absent, therefore it is called dry ice. We can give one more answer of that. When is pressure is released, the solid carbon dioxide directly convert into gas without passing the liquid. Without passing the liquid. If one thing is striking in your mind, then in the previous class we discussed about it. What this phenomena is called? The direct conversion of solid into liquid and solid into gas and gas into solid. Sublimation. Yes, that is an example of sublimation. So let me continue the topic. Since the solid directly convert into gas and gas directly convert into solid directly convert into gas directly convert into the solid, and liquid is absent, so there the the carbon dioxide do not wet the surface of container, do not wet the surface of container. That's why it is also called dry ice. Okay, clear? So after the two classes, the previous one and today's, we can say that pressure and temperature determine the state of matter, and by changing the temperature and pressure, the state of matter can easily change, can easily change. If we have to convert solid into liquid, we have to increase temperature and decrease pressure. T stand for temperature, P stand for pressure. And liquid to gas, temperature increase and pressure decrease. Oppositely, the process will opposite. That means gas to liquid, we have to decrease the temperature, increase the pressure. By decreasing temperature, increasing pressure, we can convert gas into liquid, and similarly liquid into solid form. Now I am discussing the last topic of our first chapter, which is evaporation. Which is evaporation. Do you ever listen about it? Evaporation. Let me clear you one thing, that evaporation and vaporization are different things. There is two phenomena. One is evaporation and one is vaporization. Evaporation and vaporization, both are different. Both are different. Okay. How they are different, we will discuss in the ending of that topic. What is evaporation? In daily life, you experiences various examples. Like first, when we put the wet cloth on the a wire, then after some time they becomes dry. That means the liquid convert into the gas form. But did the cloth reach at the temperature of boiling of water, that means 100 degrees Celsius? No. Below it, it converted into gas state. Similarly, in the in the winter, when you put it hot water in a bucket, the vapor is appearing, that is vaporization. Okay. Now, have you ever seen that vapors also appear on the ice? Did the temperature is 100 degrees Celsius? No. That is example of evaporation. Got it? So evaporation and vaporization are two different things. Clear? Now let me move to the topic. firstly discuss it, then we will discuss more differences that were that I discussed two examples, so you can clearly understand that these are two different things. Evaporation, what is evaporation? The phenomena of change of a liquid into vapor at any temperature, but it should be lower than its boiling point. Lower than its boiling point is called evaporation. Is called evaporation. Now the questions comes in our mind that in boiling we understand that we supplying the heat continuously, so the particles get enough energy and separate out from the liquid state. But what is happening here? To understand it, there is a diagram. The particles of liquid have kinetic energy, and because of the kinetic energy they continuously move and strike with each other. During this striking, they transfer the kinetic energy to each other. Finally, when this kinetic energy reaches to surface particles, they get enough energy to escape from liquid state and turns into gas. That means the energy transfer to here and it goes into the gas state. To understand it, let me take a simple example. Suppose in your class you are 40 student and I am your teacher, and I play a condition. I place a condition that the student which has student or students has or have 40 rupees will come out the class. In class, that means you are in liquid state, and come out the class, that means you are in gas state. Now none of the student have 40 rupees. Some of you have 22 rupees, 3 rupees, 5 rupees, 10 rupees, 20 rupees, like that. You decided that one student will go outside, and for that you transfer the your money to each other. The last line transfer to the above the frontier lines, and similarly it reaches to the frontmost line of the class. Now that students have more than 40 rupees, so they go outside, they went outside. None of the students have 40, but some of them, because of the contribution, becomes more than 40, so they go outside. Similar here, none of the particle have kinetic energy to individually transfer into gas state, but due to the transfer of the energy to each other, some of the particles get enough energy to escape from this state. That is the difference between evaporation and vaporization. In vaporization, each particle have enough energy, but here only the surface particles get enough energy to break the attraction forces and convert into the vapor or gas state. Clear? Now let me read out it. It is a surface phenomena because the surface particles goes convert into the gas, so that is a surface phenomena which occur below its boiling point. The particles of the liquid have kinetic energy which is they transfer to each other. This energy finally reaches to the surface. It results some particle of the surface having more kinetic energy break the force of attraction and get converted into the vapor state. Okay, I hope it is clear. Now let's discuss some factors which affecting the evaporation. First is surface phenomena. Since it is a surface phenomena, so it will be affected by surface area. When the surface area is increased, the rate of evaporation is also increased. To understand it, let's take an example. When you put it cloth collectively on a wire, they dry up and take longer time. But when you spread out, then they takes lesser time to become dry. Why? Because when they are collected, then their surface is less, but when you spread out, their surface area is increased. Similar example also, that suppose you are taking tea, it is hot, then you ask a plate, and when you pour your tea in the plate, it becomes cool in lesser time. Why? Because the surface area is increased. Hence, the rate of evaporation is increased. So it becomes cool in lesser time. Clear? Second is temperature. As you know, it is related with the evaporation is related with the kinetic energy, and if the particles temperature is high, then more particles get enough energy. More particles get enough kinetic energy to escape from liquid into gas state. So more temperature, more evaporation. Like that, in summer, our wet cloth dry in 1 or 2 hours, while in winter season they takes 5 or 6 or sometimes 7 hour also. Also, because in summer the temperature is high. Clear? Now the third one, that is humidity. What is humidity? The amount of water vapor present in unit volume of air is called humidity. Is called humidity. There is a question come in our mind, that why the cloth take longer time in the rainy season rather than summer or winter. They take 1 day to become dry, and if the cloth is heavy, that means more layers of the threads, then they take more than 1 day. Why? It is related with the humidity. Our air can hold a definite amount of water vapor. If there is more water vapor, then the evaporation rate is decreased, because the air cannot hold the water, and as you know, in evaporation the water went into the air, but if air is not taking the water, then where it goes? That's why in humid condition, our cloth takes longer time in drying process. Got it? So we can say the amount of water vapor, the at given temperature air can hold definite amount of water. So if the already high, that means humidity is already high, then the rate of evaporation is decreased. Okay. Now fourth is wind speed. Wind, the moving air is called wind. If the air is moving, then it take away the water vapors rapidly. Hence, the surrounding of the container in which we have water becomes have less water vapors. So the rate of evaporation becomes high. You know that in a day in which the air is blowing with high speed, our clothes dry much faster, because the air continuously take away the water vapors. Okay, so with the increase in the wind speed, the particles of water vapor move away rapidly. It results decrease the amount of water vapor in the surrounding and increase the rate of evaporation. Four. Okay, these four factors: first was surface area, second was temperature, third was humidity, and fourth was wind speed. These four factors affect the evaporation. Now there is a question comes in our mind, that is evaporation and cooling. They are related? Yes, they are related. During evaporation process, the particles absorb kinetic energy from their surroundings. The surface particles absorb kinetic energy from their surrounding. Hence, the temperature of surrounding becomes low. It results cooling. It results cooling. Got it? So, for example, in summer, we spread water on the roof. That water absorb heat from the from the roof, which results cooling the surface area, cooling the surface. Got it? Similar case you observe in coolers. The water which is falling down from the net of the cooler absorb the heat from the air, hence the air becomes cool. Okay, so evaporation increase the cooling. Now, wearing of clothes in summer. Why we wear the cotton clothes in the summer? Cotton is a good absorber, good absorbing material which absorbs sweat or water which coming outside from which coming out from our body. Now, this cotton helps in easy evaporation because it provide a large surface area, and due to easy evaporation the body temperature becomes lower, hence body becomes cool. That's why we should wear the cotton clothes in the summer. Okay, that was last topic of our chapter. Hope you enjoyed it. Thank you.